You already know that atoms are the smallest building block of matter. But did you know they don't like to hang out all by themselves in the great big universe? They're like teenage girls. They tend to hang out in little groups that we call molecules. Today, we're going to watch how molecules hold their bonds as they move through phases of solid, liquid, and gas phases of matter. All of that and more today on You Got Science. Last time you saw me model 2 hydrogen, H2, and 1 oxygen to get the molecule H2O, or water. You might find this model cool. In fact, it's freezing. When water molecules lose their energy, they form into a crystalline pattern, which you might find interesting for later. I wanted to show you these because they're so cute. In fact, scientists have more than one way to model water molecules or any molecules. It's very common to see oxygen represented as red and hydrogen as smaller, either white or gray spheres. So when water molecules are a little bit warmer, they take the form of liquid. So they still hold some attraction for one another, but they will fill the space of whatever container they're in. When water molecules become air, I forgot! I never learned how to juggle. When water molecules become air, they hold little attraction to each other at all. Now, we've been talking about physical changes. H2O molecules move through solid, liquid, and gas and maintain their shape. But there is a bonus 4th stage of matter, and that is plasma. This is what happens when there's so much energy. Molecules lose their shape. Atoms go all aggro and you get these glowing charged particles. That's what makes lightning, neon lights, and sparks. The sparks you're about to see. When you light a match, make sure the box is closed and you strike the match away from you to prevent accident. Molecules in the air become hypercharged because of the burning metal in this sparkler. That's plasma.
Speaking of sparks, he's here.
He's here?
Yes.
He's on?
It's time for Here's the Shtick with Mrs. Thicke.
He is in every river, every cloud, every ocean wave. Give it up for water. Water, I am so sorry you couldn't be here in the studio today.
Well, you knew there'd only be about a 33% chance I'd be in your area this afternoon.
Oh, he's talking about precipitation. That's when he turns from moisture, which is a gas, into liquid rain.
That's right. I'm ice, I'm rivers, I'm steam. They call me the hardest working actor in science.
Water. I have seen all your work. Solid, liquid, gas. I mean, you're so versatile. It's okay, I'm married. I'm fine. Oh my. Oh. A lot of people don't know this, but you're in air.
People don't realize it, but I'm in the air all the time. And when I take on a bigger role like fog, that's when you finally notice me. I sneak into places you don't even think about. Your breath. The clouds.
Well, I saw you once as an iceberg and you were phenomenal. Just look at the pattern water molecules make when they're in solid form.
Yes, that's my signature look when I freeze. My molecules lock into this perfect hexagonal pattern, so I actually get bigger as a solid.
Tell us about your hexagonal pattern and why it's so important to you and to all of us.
If I didn't expand, ice would sink and lakes could freeze solid from the bottom up. But thanks to me, life survives under the ice.
Just flowing with talent.
I would have come there in person, actually, but they needed me behind the bar.
Water, everybody! Hi, Mom. Did you catch my interview?
I think that guy was a phony.
You do?
I bet he's not more than 65% water.
Well, you know, most humans are made up of between 50 and 65% water. We can see that ice floats, but how do we really know that most other solids don't also float in their fluid? Well, today, Pepper here is going to demonstrate a very accurate, a very compelling, a very definitely not actually happening experiment. First, you need to gather up all the extra gold you have lying around your house. Place it in a saucepan on the stove or a hot plate. Just turn the dial to 1947 degrees Fahrenheit, the melting point of gold. You'll need a gold bar. You could pick one of these up from the Franklin Mint or the US Treasury. I think Michael sometimes has them. Time to add the gold bar. And there it goes, sinking straight to the bottom. Another reminder that most substances besides water are more dense in their solid than in their liquid form.
Do not attempt this at home. Conventional stoves and hot plates do not reach 1947 degrees Fahrenheit and should never be used to melt gold. No valuables, appliances, or molten metal were used in this demonstration. Safety gear not shown because Pepper promised she had everything under control.
That's so solid!
It does have a certain fluidity.
It's a gas! You got science! It's made possible by...
Solid keeps its shape. Liquid takes shape of container. Gas fills all space. Plasma, glowing charged particles. And this week, phase changes. Melting, solid to liquid, freezing, liquid to solid, vaporization, liquid to gas, condensation, gas to liquid, sublimation, solid to gas, deposition, gas to solid.
Every time matter changes from one form to the other, solid, liquid, or gas, it has its own special name. Oh, my drink is all wet. That's condensation. Water vapor in the air cools down in the hot lights and turned into liquid on my cold soda can. Nigel, could you bring me that glass of water I left out in the blazing sun a week ago? Oh, right. It evaporated. That's vaporization, when liquid escaped into the air and became gas. We've already covered melting. And you know freezing from those homemade summer popsicles, liquid to solid. Then deposition. Gas, straight to solid. Even the name sounds harsh. Like when your relationship with your BFF or the person you're dating feels airy and breezy one day and then hard and cold the next. That's deposition. Be comforted that this happens in nature as well, when frost or hail form directly out of the clear blue sky. Finally, sublimation. That's when a solid skips the liquid step and turns straight into gas. This is the case with the solid form of carbon dioxide known as dry ice. Observe sublimation as we drop the dry ice into warm water. Sublime! Some of you still ask questions about how air takes up space. Well, gases like air spread out to fill all the space available. Look how much space CO2 takes up as it escapes its solid form into the air. I'm going to fill this balloon with a heaping teaspoon of crushed ice. Seal it, and a minute later... Yep, sublime.
Next we have Let's Go H2O.
Unusual pom-poms.
Their accessories are really on point. Those are water molecules.
The classic red sphere represents oxygen and the two white spheres are hydrogen atoms.
Solid, solid, stuck in place. We hold our shape, we don't lose space.
Literally, this is just what water molecules do when frozen in their solid form.
I don't know, they look a little stiff.
That's because they are in their solid formation, but I think they're about to warm up.
Liquid, liquid. liquid, smooth and free, flow and pour so easily. Hotter, hotter, bubbles rise, becoming gas surprise. Come back down, don't drift away.
No more bonds, I cannot stay.
Guess she's gas now.
Nice Ariel.
Do you know that glass can go from a solid to a liquid and back again over and over again until infinity? Plastic or glass can always be repurposed or reused, but when it comes to recycling, plastic usually only gets one shot or maybe two, and then it's gone forever. Glass, on the other hand, can always change phases and be recycled. If you're careful not to throw it in the trash, it could outlive you or your grandchildren or even Paul Rudd.
Subscribe, it's free. I wouldn't subscribe either if it wasn't.